Ah, yes, the Ferris wheel. A quintessential aspect of nearly all amusement parks, carnivals, and entertainment locations. At least those worth their salt. It is hard not to get excited about cotton candy, funnel cake, and snuggling up next to your sweetie as it turns round and round when staring at a Ferris wheel. Most recently, when I looked upon one of these majestic testaments to engineering and science, I thought to myself, how can I make this better? And by better, I am, of course, thinking about scary. Worrisome that I would go there, perhaps, but it did lead me to an interesting mathematics connection to sinusoidal graphs. In the interest of time, I will forfeit the inconsequential details about chainsaws, lighting, pyrotechnics, and the guarantee that patrons will get wet, and of course, the bear. And I'm going to get straight to what really matters, the math. For a structural overview, let's take a look at the basic Ferris wheel. Excellent. Now, when pondering such a device, I thought we could build a large platform that covers the bottom half. Like this. Obviously, it would be more opaque to hide the snakes and whatnot, but you get the idea. This gives us a very nice circle and sets us up to have our X and Y axes placed here as well. And like any good creator of any scary Ferris wheel of doom, I do have to be conscious of the fire exits when it breaks down. To this end, I plan to create vertical ladders to each cart at several locations on the wheel, and this is when my piety sense started tingling. I have a right triangle! Looking at right triangles, we remember all the trigonometric ratios, yes? And the SOHCAHTOA. Looking at the basic right tri, like the one shown here, we would find our angle, that theta there. Find the side opposite the angle. Recall, opposite means far away. And put that over the hypotenuse. While we don't know what size this Ferris wheel is going to be, we do know that it will be 1 unit in length. That is, the radius of the circle is 1 unit. It's a unit circle. Unit circle. That's a great name! That's what we should call it. This is a unit circle. The result of this computation gives us an output of y for any angle that creates theta. Let's repeat this with another angle, like this one. So we find our little angle there, theta. We find the side opposite theta, which is the height, the y. Sine equals opposite of hypotenuse, which means y over 1, because the hypotenuse is still 1. So y divided by 1 is y equals sine theta. Good. Same. Let's keep repeating this with a whole bunch of these. If we go to the other side, we got the little theta there. Sine of theta equals opposite over hypotenuse. We find the opposite side, that's the y over 1. Hypotenuse is 1, y equals sine theta. We go to the next one. We got theta, opposite side y over 1, and y equals sine theta. Y equals sine theta. Y equals sine theta. Y equals sine theta. You get it. That does make a pretty cool design. In fact, now that we have a good mathematical model for the Ferris wheel, we can kind of just drop the image altogether to help us see it. There. What an awesome mathematical model. Now let's put some numbers to our unit circle. The values you see here are the angles for our special right triangles, our 30, 60, 90, and our 45, 45, 90. You can also see these in two different sets of units. The degree, which is the one you're most familiar with, and an equivalent angle that's a common unit for angle measures called the radian. Notice pi radians, and yes, that is the same 3.14 pi that you're used to, is equivalent to 180 degrees, and all other angles fall into place based on that common fact. We'll talk more about radians in the coming lessons, but for now, let's focus on degrees. This unit is connecting what we know about trigonometric functions to their corresponding graphs. To this end, let's find our y for all of these given angles with the calculations we made a few moments ago. At this time, I'd like you to get some graph paper and see what you can piece together. And we'll continue this with your finished product that we'll talk about in the next session. Good luck.